Good morning. Today's topic is commercial cells or batteries. So in a battery what happens? Chemical energy is converted into electrical energy. Okay, and also it is to be lightweight, then compact, and its voltage should vary appreciably during its use. Okay, these are the important uses of cells. So it must be lightweight. So in order to carry from one place to another, it must be light, compact, and voltage varies during its use. There are two types of batteries: primary cells and second one is secondary cells. Okay. What are the difference between primary cells and secondary cells? In primary cell, the reaction occurs only once. And after use, these batteries dead and we have to throw it. Okay. But in the case of secondary cells, we can reuse them, because once the charge becomes zero, we can again recharge it and use. So we can reuse secondary cells. Okay. Whereas primary cells we can use only once. Examples of primary cells are dry cell, or we can say Leclanche cell. This is the figure. Then second one is mercury cell. Here we are discussing first about dry cell. Okay. What is a dry cell? Dry cell, they are mainly used in transistors and clocks. Okay. And clocks we are using dry cell. Transistors and clocks. Now it contains anode and cathode. What is anode? Anode is a zinc container. From the figure you can see there is a zinc container, zinc cup, which acts as anode. And what is cathode? Cathode is graphite rod or carbon rod. Okay, carbon rod surrounded by magnesium dioxide. And carbon black. Okay. These are the two electrons present in dry cell, and there is a gap between these this cathode and anode. These are filled, the space between these electrodes are filled by moist ammonium chloride and zinc chloride. Okay. This is the figure. So dry cell is also called as Leclanche cell. Okay. Zinc anode and carbon cathode. This carbon cathode surrounded by magnesium dioxide and carbon, and the gap is filled by ammonium chloride and zinc chloride. Now what is the reaction? At anode what happens? Zinc is in the solid state, solid form. It gets converted into Zn2 plus 2 electrons. 2 electrons are liberated. And what about cathode? Cathode, MnO2 and NH4 plus are present. Okay, NH4Cl, NH4 plus is present, and 2 electrons are absorbed and it gets converted into MnOOH. So here what happens? Plus 4 oxidation states gets converted into plus 3 oxidation state, Mn plus 4 to plus 3, and ammonia gas is liberated. Okay, this is the reaction taking place at cathode and anode. Okay, now this ammonia produced, the zinc chloride is present. So Zn2 plus is present, and this ammonia, what happens? They form a complex with zinc and form ZnNH3 4 times. A complex is obtained. Okay, so these are the reactions taking place in dry cell. Okay, now what will be the voltage? The potential of this cell is 1.5 volt. Okay, potential is 1.5 volt. So these are the important points of dry cell. Now let us discuss what is mercury cell. So mercury cell, this is a picture for mercury cell. It is a primary cell. We can use only once. Then after one use it becomes dead and we have to throw it. This is used in low current devices like Examples like these hearing aids, then calculators, etc. We are using this in watches, etc. Okay. Now it contains anode and cathode. So anode is, see the figure, this is a small cut, inside portion is given here. So it contains anode. Anode is zinc mercury amalgam. Okay. And what about cathode? Cathode is inside. This is a cathode. This portion is cathode, and above that there is anode. Okay. And there is a separator in between this cathode and anode. This is a cell can, okay, gasket, and there is an anode cap. So anode is zinc mercury amalgam, and cathode is a paste of mercury oxide and carbon. Okay. This is cathode. And electrolyte is present in which the anode and cathode are kept. So what will be the electrolyte? Electrolyte is a paste of potassium hydroxide and zinc oxide. Okay. Paste of potassium hydroxide and zinc oxide. This is electrolyte. Okay. In which the anode and cathode are kept. Cathode is a paste of mercury oxide and carbon, and anode is zinc mercury amalgam. Now what is the reaction? Reaction at anode, what happens? Reaction at anode. At anode zinc is present, zinc mercury amalgam. Zinc mercury amalgam with hydroxide, OH minus. Because potassium hydroxide and zinc oxide is present, so OH minus is present, reacts with ZnOH and form zinc oxide. Zinc oxide, H2O, and 2 electrons are liberated. Anode, this reaction is taking place. Zinc amalgam reacts with OH minus present in the electrolyte and forms ZnO, H2O, and 2 electrons are liberated. Okay. Now cathode, what happens? HgO is present at cathode. HgO, mercury oxide is present. Okay. Water is there. Accepts those electrons. Okay. And form Hg plus H2O plus 2H minus. Okay. Balance 2H minus. So mercury oxide with H2O, 2 electrons are present. Those absorbs those electrons and form mercury liquid, and 2OH minus will be produced. Okay. The overall reaction, what will be the overall reaction? Zn amalgam. Then the present HgO. Okay. Is cancelled and form ZnO plus Hg. This is the overall reaction. This will be the reaction in case of mercury. And what will be the cell potential? Cell potential of this cell is 1.35 volt. 1.35 volt. So this much about mercury cells. Okay. So next we are discussing on secondary batteries. Secondary batteries. The main advantage is they can be reused. Okay. After use, they can be recharged by passing current through it in the opposite direction. Okay. So it can be reused. It's an important advantage. So okay. Examples are lead storage cell. Then nickel cadmium cell. These are the examples. So in this case, the recharge by passing current in the opposite direction. Okay, so we can recharge them. Now, first one, lead storage cell. What about anode and cathode? Here anode is lead. Okay. Lead is the anode, and cathode is a grid of lead packed with lead oxide. Okay. A grid of lead packed with lead oxide. Now, electrolyte is present in which cathode and anode are present. So, electrolyte is 38% solution of H2SO4, sulfuric acid. Okay, H2SO. This is the solution. So, aqueous sulfuric acid, 38% sulfuric acid. Now, what will be the reaction at anode and cathode? And also the overall reaction. Anode. Anode, what happens? It contains lead and also SO4 2 minus. Sulfuric acid, H plus and SO4 2 minus. So, it contains SO4 2 minus. Okay, gets converted into PbSO4 plus 2 electrons are liberated. Now, what happens at cathode? Cathode, we know lead oxide is present. Okay, lead oxide. Also, it contains SO4 2 minus 4H plus. Sulfuric acid is present and 2 electrons are accepted. Okay. Now, what happens? Now, PbSO4 is obtained. Okay, plus 2H2. This will be the reaction. Now, what will be the overall reaction? Overall. Now, lead present, lead oxide. Okay, PbSO4. Then, it contains 2H2SO4. Okay, 2H2SO4 gives 2 PbSO4. PbSO4 plus 2H2. Okay. This will be the overall reaction. Now, while charging the battery reaction, we can reuse it by recharging. Okay. So, while charging, what happens? The battery reaction is reversed. Okay. So, PbSO4 on anode and cathode is converted to lead and lead oxide. So, this complete reaction gets reversed during recharging. Okay. This much about lead storage battery. Now, second one is nickel cadmium cell. Now, the second type of secondary battery is nickel cadmium cell. Okay. Now, it has longer life than lead storage cell. Okay. But what is its disadvantage? It is more expensive to manufacture. Okay. Now, it contains anode and cathode. What will be anode? Anode is cadmium metal. Cadmium metal acts as anode. And what will be cathode? Cathode is nickel 3 compounds. Nickel 3 compounds supported on nickel. Okay. Supported on nickel acts as cathode. Now, supported on nickel acts as cathodes. Now, what will be the reaction at cathode? Anode and cathode. First anode we can take. Anode. Cadmium is present. Okay. And OH minus. OH minus is present. 2OH minus. So, gets converted into CdOH twice. Okay. And electrons are removed. 2 electrons. Now, at cathode what happens? Nickel 3 compounds. NiOOH. NiOOH solid is a compound of nickel. Okay. With H2O is present. Okay. Plus 1 electron is accepted. And it gets converted into NiOH twice plus OH minus. Okay, NiOH twice and OH minus are produced. Okay, this is the reaction. So, what will be overall reaction for that? We have to multiply this whole reaction by 2. So, what happens? Overall reaction. Cadmium is present. This reaction plus NiOOH twice Okay, because multiplying by 2 plus 2H2O, electrons, electrons, 2 electrons, 2 electrons get cancelled. Now, what happens? CdOH twice is present. Then, 2 NiOH twice. Okay, 2 NiOH twice is also present. So, this is the overall reaction. Okay, anode this reaction takes place and cathode this reaction is taking place. So, overall reaction will be like this. Okay, so this much about secondary batteries. This is the second cell, secondary battery, second example nickel cadmium cell. So, this much about batteries or commercial cells. Okay.